We're asked to write out all the functions f that map the set with elements 1 and 2 to the set with elements a, b, and c in two-line notation, where the domain is a set with elements 1 and 2, and the codomain is a set with elements a, b, and c. Because we have 2 inputs and 3 possible outputs, 3 times 3 is equal to 9, there are a total of 9 functions. Let's name the functions f sub 1 through f sub 9. For each function, there are 2 possible inputs, 1 and 2, and the inputs go in the first row of the matrix for the function in two-line notation. And now let's list the possible outputs from the codomain, which is a set with elements a, b, and c. So for function 1, let's let both outputs be a, meaning 1 maps to a and 2 maps to a. For function 2, let's let both outputs be b, meaning 1 maps to b and 2 maps to b. And for function 3, let's let both outputs be c, 1 maps to c and 2 maps to c. And now let's let the outputs be a and b, where 1 maps to a and 2 maps to b, or 1 maps to b and 2 maps to a. And now let's use the elements of a and c, where 1 maps to a and 2 maps to c, and then 1 maps to c and 2 maps to a. And now let's use the elements of b and c for the outputs, where 1 maps to b and 2 maps to c, and 1 maps to c and 2 maps to b. Number 1, how many functions are there? We know there's 9. Number 2, how many are injective? A function is injective provided every element of the codomain is the image of at most one element from the domain. So analyzing the functions, f sub 1 through f sub 3 are not injective because for each function, the one element from the codomain is an image of 2 elements from the domain. Notice for function 1, the element of a from the codomain is an image of 2 elements from the domain. For function 2, the element of b from the codomain is an image of 2 elements from the domain. And for function 3, c is an image of 2 elements from the domain. However, functions f sub 4 through f sub 9 are injective because the 3 elements from the codomain are images of exactly 1 element from the domain, or 0 elements from the domain, which does satisfy the definition of every element of the codomain is an image of at most 1 element from the domain. At most means 0 or 1. So there are 6 functions that are injective. Number 3, how many are surjective? A function is surjective provided every element of the codomain is the image of at least 1 element from the domain. Well, we can quickly see from all of these functions, none of them have 3 outputs, and since the codomain contains 3 elements, none of these functions are surjective. Functions f sub 1 through f sub 3 have 2 elements from the codomain that are not images of 1 element from the domain, and the functions f sub 4 through f sub 9 all have 1 element from the codomain that is not an image of 1 element from the domain, which again indicates all the functions do not satisfy the requirement that every element of the codomain is an image of at least 1 element from the domain. So number 3 is 0. Number 4, how many are bijective? Bijective functions are both injective and surjective, and therefore there are 0 bijective functions. In order for a function to be bijective, the number of elements in the domain and the number of elements in the codomain must be equal. I hope you found this helpful.